Good morning, everyone. Welcome to day 2 of the Transfer to Excellence Summer Research Symposium. For anyone that didn't join us yesterday, we had a great day of 10 presentations of our summer interns, and we're really happy to be back here. My name is Nicole Mcintyre, and I'm the director of the program. This was another year affected by the COVID-19 pandemic, but we were able to host a cohort of 19 remote interns who logged in every day and did their research and their meetings all on Zoom. And that included 19 amazing graduate student and postdoc mentors and 17 different research centers supporting the students. And by many measures, this year's intern cohort was our most diverse ever, which is very exciting. The presentations you'll see today were supported both by the Hopper Dean Foundation and the National Science Foundation REU program. The program was also hosted for the 10th and final year by the Center for Energy Efficient Electronic Science, which is a National Science Foundation research center. So some quick logistics. This meeting is being recorded. However, it should mostly just be anyone speaking whose video is captured. We have muted all audience members, but we really encourage you to engage with our presenters by asking questions following each presentation. You could answer your questions in the chat or just unmute yourself and ask them. I will get rid of the dogs behind me in a minute. So today we're going to start off with Christopher talking about the work he's done in the lab of Professor Laura Waller, moving on to Aneri, Emmanuel, Fayaz, and Amy. We'll then take a short 10 to 15-minute break and resume with Kayvon, Idris, Ire, and Afnan. And we are so grateful to the graduate students, postdocs, and professors that you see listed on these slides for supporting these students through the last 9 weeks. And with that, Christopher, if you are ready, we will hand it over to you to kick us off.
All right, thank you. Let me share my slides. All right, does it look good to everyone?
Looks good.
Okay. Hello, everyone. My name is Christopher Galcott, and I'm a student at Consumers River College. The work that I'll be presenting today is titled End-to-End Design of a Snapshot Hyperspectral Microscopy System, and this work was conducted in the Computational Imaging Lab at UC Berkeley, led by Professor Laura Waller, under the guidance of my mentors, Eric and Dirja, as part of the 2021 TTE REU program. So let's talk a little bit about hyperspectral imaging. So there's many ways to represent color in imaging. Traditional red, green, blue cameras capture color in 3 spectral bands, red, green, and blue channels. Multispectral imaging, denoted as MSI here, capture a small number of spectral bands, but still more than RGB. And hyperspectral imaging aims to capture narrow spectral bands over a continuous spectral range. Additionally, hyperspectral imaging aims to capture a 3-dimensional hyperspectral data cube in which the X and Y spatial dimensions of the image also contain the intensity across wavelengths, which can be thought of different color channels. This means that by using hyperspectral imaging, we can obtain much more spectral information than standard RGB or multispectral cameras. So why is this important? Hyperspectral imaging is useful and important for many applications in biomedical imaging, ranging from identifying fluorescent labels in cells to classifying tumor tissues and cancer cells. So how do we capture a hyperspectral data cube? There are many methods ranging from wavelength scanning, which uses filter wheels or other tunable filters, point scanning, which scans a point spatially, push broom methods, which scan a line spatially, and snapshot methods, which aim to capture the full 3-dimensional hyperspectral cube simultaneously, but trade spatial resolution for temporal resolution. So in this work, we're only focusing on snapshot methods. And recent work in our lab has shown the feasibility of Spectral Diffuser Cam, a compact lensless snapshot hyperspectral imager with high spatial spectral resolution that makes use of a diffuser and a spectral filter array And how this works is that the imaging forward model captures a coded measurement, and then this is passed into a reconstruction algorithm, which is used to recover a hyperspectral data cube. And we can break this up into two core parts: the imaging forward model, which takes in a scene and outputs a measurement, and the reconstruction algorithm, which takes in a measurement and outputs a recovered hyperspectral data cube. So let's talk a little bit about what end-to-end design is. End-to-end design, also known as data-driven design, is a method where we learn both the hardware parameters and the reconstruction parameters through backpropagation. We can break up end-to-end design into four parts: the input, the hardware, the reconstruction algorithm, and the output. At the end of all of this, the output is then compared to the ground truth, which is the input, and the loss, or the difference between these two images, is calculated. Then we calculate the gradients of the loss function with respect to the learnable parameters and update the parameters of our system to minimize the loss. And this process is known as backpropagation. And this is what allows our system to optimize the hardware and reconstruction parameters over a specific set of data. And recent advancements in end-to-end design of computational imaging systems and their reconstruction algorithms have led to improved system performance for single-shot HDR, extended depth of field, Fourier ptytography, microscopy, and many more areas in comparison to heuristically designed systems, which don't change based on the sample data. So we hypothesized that using an end-to-end design of a snapshot hyperspectral microscopy system will outperform heuristically designed systems, such as Spectral diffusicam. Additionally, our design is implemented in the microscopic domain rather than the macro scale domain. And once again, we can break up our design into two main parts: the imaging forward model and the reconstruction algorithm. So let's look at how our hyperspectral data cube scene passes through our end-to-end design. We'll start with the diffuser, but before we go into how to calculate the diffuser, we have to dive into lensless imaging to understand why we use a diffuser. So traditional imaging with a lens maps a point source in our scene to a point source in our sensor, one-to-one, whereas a diffuser spreads the light from one point source in our scene to many point sources on our sensor. And this looks kind of like a caustic pattern as seen on this right picture here. And this diffuser is approximately linear shift invariant. However, we will model this diffuser's point spread function, or PSF, as fully linear shift invariant in our imaging forward model. So let's take a look at how we can calculate the measurement as the scene passes through our diffuser. First, we take the scene. Then we can do a two-dimensional convolution across the X and Y spatial dimensions. Next, we crop our result to obtain the final measurement. And this is because we have to account for the size of the point spread function in addition to our sensor size. And now we can repeat the same process for the entire scene across all of the spectral dimensions. However, since the point spread function is consistent across spectral bands, we can calculate this diffuser measurement as just taking the convolution of the scene with our linear shift invariant point spread function. And finally, we obtain a point spread function measurement outlined in yellow, which is the result of the scene passing through the diffuser. And note that this measurement is 3D. Next, let's look at how our point spread function measurement passes through the hyperspectral filter array and hits the sensor to produce a two-dimensional sensor measurement. So our design uses a hyperspectral filter array made up of an 8x8 grid of filters that is glued onto the sensor, so we can capture the hyperspectral information from the sensor. Additionally, we can see here that a cyan filter has a filter response as so, where there's about a peak at the 500 nanometer wavelength. And the x-axis here is in nanometers. And each hyperspectral filter follows a Cauchy distribution, also known as a Lorentz distribution. Additionally, we can see the same for this red filter. And this hyperspectral filter array, as noted earlier, is an 8x8 grid, but we will repeat this across the entire sensor. So here's what it might look like. So once we have this hyperspectral filter array cube, which is in 3 dimensions, as the third dimension is the spectra, we can pointwise multiply this by our point spread function measurement and take the sum across all of the spectra to obtain a two-dimensional coded measurement, where the 2 dimensions are just the y and x. spatial dimensions. So now that we're done with our imaging forward model, let's take a look at why we need to do a Wiener deconvolution before we input this code and measurement into our reconstruction algorithm. So since a diffuser tends to spread light over the hyperspectral filter array and sensor, we need to use a Wiener deconvolution, which is an application of the Wiener filter to bring the measurement a little closer to the ground truth or the original image, so we can easily reconstruct for training and reconstruction purposes. So once we obtain a recovered measurement from the Wiener deconvolution, we're able to finally input this recovered measurement into our reconstruction algorithm. So for our reconstruction algorithm, we use a U-net-based approach convolutional neural network, which takes in a two-dimensional recovered measurement as the input and outputs a three-dimensional hyperspectral data cube that is recovered, where the three dimensions are spectra and spatial dimensions. And the way that this U-net works is that there's an encoder path and a decoder path, in addition to skip connections, which preserve the various features. So now let's take a little look at our loss function to see how our design learns to update the various parameters in our hardware and reconstruction algorithm. So for our loss function, we're going to use mean squared error, and this means taking the ground truth or the original image and subtracting that, or finding the difference between the reconstruction or the predicted image. And we're going to square this result and take the average of it as our loss function. So now that we have calculated the loss, we'll perform backpropagation, as mentioned earlier, by calculating the gradients of the loss with respect to the learnable parameters. And then we will update the various parameters of the reconstruction algorithm and the hyperspectral filter array to minimize the loss and try to obtain a better reconstruction that closely matches our original image. So in summary, our design captures a 2D measurement of our scene onto the sensor, then uses computational imaging using this 2D measurement to create a 3D reconstruction of the original scene. So now that we have seen how our model works and how our end-to-end design works, let's take a little look about our results. So our experimental setup is comprised of 320 different hyperspectral data cubes consistent of green and orange beads of different sizes. And 6 of them are shown here, for example. Note that these are actually 3-dimensional, but I'll just show them in 2-dimensional for your reference here. And here we can see that the orange beads produce an intensity around 610 nanometers, whereas the green beads produce an intensity about 508 nanometers. So let's take a look at the initial hyperspectral filter array, which contains 64 unique filters that are evenly spaced from 400 to 784 nanometers. And these filters are randomly located on the initial hyperspectral filter array. And our goal is to try to optimize the layout of these filters. So here we can see an animation of our end-to-end design jointly optimizing the hyperspectral filter array in addition to the reconstruction algorithm over 1200 epochs. And on the right here is the intensity versus wavelength graph, which shows the filter distributions as mentioned earlier. So here's a snapshot of the final jointly optimized hyperspectral filter array. And let's zoom in onto this graph to see the differences between the initial and the jointly optimized one. So like I said earlier, we're imaging green and orange beads, which are at 508 nanometers and 612 nanometers. So we can see that the initial hyperspectral filter array contains evenly spaced filters in both of these ranges, whereas the jointly optimized hyperspectral filter array contains many more filters in these ranges, which implies that our hyperspectral filter array is capturing much more data of interest based on our simulated data set. Additionally, here's a reconstruction comparison of the fixed hyperspectral filter array and our end-to-end design of a jointly optimized hyperspectral filter array on the right. Here's a snapshot after 1200 epochs. And let's zoom into a patch to see the differences. So we're going to zoom onto this top patch here for all these images. So as we can see, The jointly optimized hyperspectral filter array in our design correctly reconstructs the correct colors for this image patch, whereas a design that does not optimize the hyperspectral filter array does not correctly recreate some of these colors. Now let's take a look at the distributions for some of the beads. So looking at the distribution where Y is the intensity or photon count and X is the wavelength in nanometers, we can see that our jointly optimized hyperspectral filter array performs much better and much closer to the ground truth's normal distribution. Additionally, we can see the same for this other bead. So we tested on a separate data set of 32 hyperspectral data cubes of green and orange beads as well to get these results. And note that we got a higher peak signal to noise ratio and a higher normalized mean squared error. And for your reference, a higher peak signal to noise ratio is better and a lower normalized mean squared error is better. So in two metrics, our end-to-end design performs a lot better than heuristic designs. So for future work, we plan to jointly optimize the diffuser, explore other reconstruction algorithms, extend this to a classification problem, and finally plan to assemble and manufacture an optimized design in the lab. So in conclusion, we have successfully introduced an end-to-end design for a snapshot hyperspectral microscopy system in which our jointly optimized design outperforms heuristically designed systems such as spectral diffuser CAM. And we have developed a framework for sample-specific design in microscopy. I would like to thank my principal investigator, Professor Laura Waller, and my mentors, Eric and Nirja, for all of the amazing help, and in addition to all the amazing individuals in the computational imaging lab at UC Berkeley. And thank you to all the program staff from the TTE REU program and all my peers for making this summer research experience possible. This work was funded by the Hopper Dean Foundation, and the TTE program is supported by E3S. Here are my references. And does anyone have any questions?
Christopher, great presentation. I have a question regarding your deep learning algorithm. What language did you write this algorithm in?
Yeah, so we implemented our whole design in Python, and more specifically, we used the PyTorch libraries in addition to NumPy. And I would love to go into more detail about anything like our UNet or maybe how we learned the hyperspectral filter array with you offline if you would like to.
We have a question in the chat from Fayaz. He was wondering, does the reconstruction ever add any extra beads, or does it only produce a loss of the beads?
So that is a good question. Let's take a look at our reconstruction here. So in my experience, it seems like the reconstruction typically doesn't add beads and doesn't hallucinate beads. However, since we're using a diffuser, our field of view is a lot smaller, and sometimes we miss beads that are on the edge of our data set.
Christopher, I have a question. You have showed this method is better than the heuristic design in like accuracy, but is there any chance that the reconstruction progress would make this a lot slower than the normal process without reconstruction?
Yeah. So are you asking in regards to other designs such as spectral diffuser CAM?
Yeah, I still like, what is the drawback of this design?
Yeah, good question, Tony. So our design actually takes slightly more computational power because we are computing, we're using auto differentiation in PyTorch to compute the gradients when we do backpropagation. So that requires more graphics card memory. However, once we train a model fully, it requires the same exact computational power to evaluate the model. So there's no drawbacks after we train a model.
Thanks. There's another question from David in the chat. What are some potential applications you can see this being implemented in?
Yeah, so as stated earlier, hyperspectral imaging is extremely useful in identifying fluorescent labels in cells and also classifying different tumor tissues. And we're planning to apply our design to image fluorescent beads in the lab. And hopefully we can apply this to other applications as well in the future.
Thank you, Chris.
Hey, Chris, there was an assumption that was made at the beginning about how the diffusion process is working. I can't remember the terminology you used, but I was wondering if you could go into a little bit more detail about how that assumption would affect the results.
Yeah. So since we assumed that the diffuser is linear shift invariant, which means that this caustic pattern is the same no matter how we move up and down, or left and right, kind of spatially. This allows us to easily compute our calculation as just using the linear shift invariant point spread function in comparison to using all of them. And this generally is safe to assume. However, once we get to like the edges of our results, perhaps seen in our reconstruction here, where it doesn't capture all of the beads, that's where our assumption might come to a downfall.
Cool, thank you so much. Great presentation.
Thank you.
Well done, Christopher. Congratulations. With that, we are going to move on to Aneri from Long Beach City College.
Okay, can everybody see my screen?
Looks good.
Yep.
Hi, everyone. My name is Aneri, and I'm from Long Beach City College. I'm really grateful to be here today, and I'll be presenting some work that I have been doing this summer in collaboration with the San Francisco Unified School District, which is also called BSFUSD. So I worked on engaging families in co-designing the student assignment policy, and I've been doing this work under the mentorship of Tanya Nguyen at Professor Nilofer Salehi's lab. So before I get into any specifics of my research, I would like to share what the student assignment policy is. Well, it is a socio-technical system that uses a matching algorithm to allocate students to school. And this algorithmic student assignment, which is also known as school choice, it allows students to choose any school in the district that they wish to attend. So now I'll share why this algorithm was introduced in the city of San Francisco. Well, the San Francisco city has racially segregated neighborhoods, which actually led to racially segregated schools. And this led to a significant difference in access to education resources for different racial groups. And in order to address this issue, in 2011, the SFUSD established the student assignment policy. It was, and to the locals, they actually called it the lottery, and the district hoped that it would integrate the classrooms. So the algorithm that they implemented was called the top trading cycles. And for a really high overview of the algorithm design, so we have a two-sided market here, where on one side we have the students and the parents, and on the other side we have the schools. So the parents are asked to submit a rank preference list of the school that they want the children to attend. And if two parents have a tie in their preferences, the school district introduces tiebreakers, where one applicant can be prioritized over the other applicant on the basis of siblings or their address or other categories like that. So in theory, the school assignment algorithm would lead to optimal assignments, and that would lead to racially and socioeconomically integrated classrooms. But however, what ended up happening in reality was that this policy failed to tackle school segregation, as we can see in the New York Times articles, that it made it worse. So this policy did not reverse racial isolation. It lacked transparency, predictability, and simplicity. And this algorithm was seen as increasing inequity. So in this research, we are going to be looking at some of the issues that have come up when these algorithms have been deployed in practice. So it took a lot of time for the parents to understand the policy and find information about the schools. And the schools offered unequal access to resources. So it was a very confusing and a stressful process for the parents. And the algorithm, instead of improving the diversity in the schools, it actually decreased the school diversity. So the prior literature found out that the algorithm didn't work because the main element of the algorithm design was preferences, and the parents had segregated preferences depending on their race and the income. So the algorithm did not have the parameters to include the social context of the marginalized families. So the algorithm failed to meet the school district goals, and a need arose to redesign the school choice algorithm. So in 2018, the SFUSD passed a resolution to redesign the school assignment system. So the district's goals of the new system were to increase diversity, proximity, and predictability. So we partnered with the SFUSD to engage underserved parents in this process. So my research question was that how can we engage underserved parents in the process of co-designing the school assignment algorithms such that their preferences as a stakeholder are taken into consideration? I am just a minute. Okay, I apologize for that. Yeah. Okay. So moving on to the methods of my presentation. So we recruited underserved parents through the process of snowball sampling. So we worked with community leaders to find families of colors and of low socioeconomic status. So for the data collection, we constructed our data set by conducting 2 semi-structured interviews over the phone. And then we also talked to a school principal, and then we had 4 meetings with the SFUSD staff to collaborate and communicate about our work. The only limitation about our data set was that we spent a significant amount of time in reaching out and building relationships with the community heads. So for the data analysis, we performed inductive and qualitative analysis of the interview transcripts. The approach for our analysis was the grounded theory method, and we performed open coding and the sorting of codes in MaxQDA, which helped us to find the common themes. So using coding and recursive abstraction, our community engagement revealed the gaps between the algorithmic assignment system and the lived experiences of the marginalized parents, which the algorithm could not account for initially. So in the next few slides, I will be explaining what those gaps were. So the first gap that emerged was proximity and transportation. So we found that the marginalized parents and the community advocates prioritize proximity and transportation. And it was their most common need. So it was not feasible for the parents to drive their children too far every day. And if the parents didn't have a mode of transportation, their children would not go to school at all. So having too many choices actually placed marginalized parents' schools too far away from their home, and that led to more issues in their child's education. So the next gap that emerged was the sibling type, was the limitations of the sibling tiebreaker. The sibling tiebreaker assigns the younger sibling to the older sibling school. However, it does not work the other way around. So marginalized parents who wanted their kids to attend to the younger child's school, they were caught in this bureaucratic process where the older child could not transfer to the younger child's school. So we interviewed a co-educational rights holder of a foster family. And so the legal guardian of that foster family was a 19-year-old who attended community college. And then the legal guardian was supposed to take care of 4 other siblings. So 2 of their younger siblings were at the elementary school level, and then they were placed at different schools, and then they didn't have any mode of transportation. So when we asked them about their experience with the student assignment system, she shared that I think she wanted to make it easier because she had 4 siblings to take care of. The 2 younger siblings at least will be together or be close to one another. And then when we asked her about what her concerns were, or if she found any barriers with the school assignment, she shared that my concern was that if they didn't end up in the same school, they're just not going to go to school. So this is a really sad situation that the elder sibling had to struggle with their education over assignments, whereas the younger sibling would not have been in this situation in the first place. The next gap that emerged was the time and information cost for navigating the system. So we found that the marginalized parents had difficulty navigating the system due to a lack of institutional knowledge. When we asked them about how did they find information, they said that they felt frustrated with the school assignment because they did not get their preferred school, and they felt distrust towards the district when the district did not respond to them in the timely manner. So the co-educational rights holder I mentioned about from the previous slide, when we asked her about that, how did you try to find information about the school assignment? She said that I was just emailing the district, trying to get a little more detail, but then the district did not respond them in a timely manner or did not respond to them at all. And then she shared that the legal guardian was also trying to reach out to the district for help because her situation was unique. So she shared that someone really liked to hold their hand or just kind of listen to them. And because, she understood, but she felt like they weren't listening to her as far as her concerns and crisp, unique situation. So they reached out for help, but they felt like they were not being listened to. So they reached out to their social ties, like their friends or their coworkers or their advocates. So the recommendations that surfaced from here were that the co-education rights holder, they expressed that my preference would be to able to meet them and have a one-on-one sort of liaison. And the community advocates, they also suggested that the school district should increase staffing during the peak admissions or the appeal season so that the parents would not have to wait weeks to get a response. So these recommendations would best support the marginalized parents and streamline information for them. The fourth theme that emerged was the inequitable distribution of resources and diversity. So through their social ties, families found out that some schools were offering more resources for a certain ethnic background than the other schools were. So the parents of that ethnic background, they actually wanted their children to attend that school. So when we interviewed a Filipino immigrant parent, she was very clear about her preferences with the school. And when we asked her about her preferences, she said that they need to be in a like Asian or Bessie Carmichael school because I don't want them to get culture shock. So they wanted their children to attend the school which had children of the similar ethnic background and such that their culture and their values would be respected. The fifth theme that emerged was limited support for immigrant and foster children. So when the foster children move from one foster home to another foster home, or when the immigrants arrive in the country, they often do this during the middle of an academic year. So it is very difficult for them to find open spots in the schools. They don't know who to contact, and it is a very difficult process for them. So a recommendation that emerged from here was that a specific percentage of seats should be reserved for students of such categories, so that they don't have to struggle to find open spots. And then the co-education rights holder also mentioned that it was very important to understand English because the district offered translation support, but despite of the support offered, it could be very difficult to navigate through the system. So moving on to the conclusion of my presentation, so our findings revealed that edge cases, which were specific to various social contexts or inequities, they were not factored in when the original school assignment algorithm was designed. So the school choice algorithm, TTC, it was just a layer to the student assignment system, but it was not the entire system. So our findings suggested that the edge cases, like the immigrants or the foster children, they required personalized or nuanced information, which they could receive, which they did not receive from the dashboard style website or from the algorithm, but they instead received it from the bureaucrats of the system or from the street level bureaucrats, which were their friends or co-workers, and the human bureaucrats of their system were the district workers. So when the algorithm is subjected to such a novel situation, it is very likely that the algorithm will make an erroneous judgment. But when the street level bureaucrats are given such a situation, they analyze and they reflect on the situation and they construct the rationales based on that. So our suggestion as a stopgap solution for this could be that whenever an algorithm is subjected to a novel case, it should redirect it to a street level bureaucrat. And in future, when the intelligent algorithmic systems will take up the roles of these bureaucrats, they will need to establish reflexivity to examine the repercussions of their decision before the decision is made. And another key point that came out was that the minority families, they sorted out schools that had resources specific to their cultural and ethnic background. So this finding made us question whether the community wanted diversity as a metric in the school. So the SFUSD's diversity goals may remain unmet, but our findings did not highlight a need for diversity, but instead they highlighted a need for educational equity between different racial groups. So these are the references that I used to prepare my presentation, and these are the acknowledgements. So I would really like to thank my mentor and my PI. They helped me a lot with this presentation, and they guided me, and they have taught me a lot. I would also like to thank Nicole, Tony, and Sam for their help, and everyone in the program. You're all amazing. I would also like to thank the SFUSD staff for sharing their insights. I would also like to thank my family for motivating me. This research was funded by the Hopper Dean Foundation, and I would like to thank the E3S Center for hosting this program. So these are the key points from my presentation, and now I would like to open the room to questions.
Hi, Neri. Great presentation. It was excellent. And kind of my research also deals with interviews, but I didn't have the privilege of actually conducting an interview. I want to know, how did it feel like doing that? How was your experience with that?
I felt, Amy, I'll be honest, I felt really, really great. And I felt privileged to help these students because, I only got the chance to conduct 2 interviews, but it was really, you feel really great because we were not expecting them to be edge cases. But it happened out that both the interviewees, they happened out to they actually turned out to be edge cases, and we got really, really rich and insightful data. So I am glad that I was that I could actually conduct those interviews. It is a really good experience. Other questions? Wait, do we have questions in the chat?
We have a question in the chat, Ineri, from Darren, who says, how might this work be expanded upon going forward?
As I said, so when we hand over this work to the machine learning models, or maybe to the artificial intelligence department, they should establish reflexivity. Although I actually read a research paper where they said, that research paper was actually in the past, and they said that at that time, the machine learning models were not as developed as they are now. So they could not, so they did not expect a lot of, they did not expect them to do the same kind of work which the human bureaucrats could do in the system. But now with the advances in the machine learning, I'm sure that that the algorithm will be able to, the new algorithm should be able to handle these edge cases without the training data. And it should be able to establish reflexivity so that it can analyze the implications of its decision before the decision is made.
Awesome. Okay, last question.
Marie.
Yeah,
go ahead.
Hi. Really interesting. Greatly enjoyed your presentation. My question is more, how hopeful are you that, even with great algorithms, this problem can really be, addressed to the satisfaction of everyone involved? I think one thing that at least came out of your presentation is, we are all individuals. We all have different ideas, different goals, especially when it comes to our children and their education. And it, I don't think I think the intentions were very good at the beginning, but just what happened was, human interactions and human desires that really got in the way. Do you think it's just a fundamental problem, or do you really think it's just a problem that the algorithms were not good enough, and that that administrators and so on couldn't handle these demands?
Well, I believe that no matter how hard we try, how hard we try to improve the algorithm, there will be some things that will always be left out. But that's the hope with that's the hope with the artificial intelligence and the machine learning models, that they can give, that they should be able to give everyone the personalized information that they need at the time of enrollment. So that's the hope, but it is very difficult to satisfy everyone's expectations and everyone's preferences. I really hope that we can do that.
Great. Thanks a lot.
No problem.
Great work.
Thank you so much.
Well done, Aneri. With that, we are going to move on to Emmanuel, who worked in the lab of Professor Anke Dragan.
Oh, hello, everyone. All right, can you see my slides?
Looks good.
Okay. Hello, my name is Emmanuel Navarro, and I'm a computer science major at Cabrillo College. This past summer, I was conducting remote research at the Interact Lab through the Transfer to Excellence program. My field of research is human robotic interactions, specifically jointly inferring human irrationality and intent. So in the future, we want to have robots. In the future, we want to have autonomous driving vehicles and robots augment their capabilities by learning through human demonstrations. Human demonstrations could be given to learn a desired task, such as guiding a robot to mimic a grasping action with a robot's gripper, or have an autonomous vehicle follow a preferred path demonstrated by a human. We want to be able, so the motivation. So we want to be able to train robots and computers to learn through the human demonstrations, and this would allow for data efficiency where large sums of data are not needed to train a robot. Another advantage is if you have a good teacher, you could potentially learn a task faster. In addition, not all problems are easy to write out as mathematical formulas. Sometimes a simple demonstration is easier. And then finally, not everyone is a computer science major and is able to write algorithms for their robots to execute. So often, we tend to assume the human demonstrators are acting rational with the best interest of performing a desired task. Most learning from reward demonstration approaches assume that the demonstrator is closely to optimal, but that's not always the case. A human demonstrator could be irrational, such as myopic or overconfident with their abilities when performing a task. These types of demonstrations could cause a learning experience that may lead to an undesired outcome, such as being short-sighted when making a decision or learning the wrong behavior in all. So our research question was, can we learn from suboptimal demonstrations under a human bias? So now we're going to transition into talking about reward learning and Bayesian reward learning. So how do we model reward learning? Well, given a grid world as an example where we simulate a robot interface, each tile here is a state where a robot may traverse, which has a set of actions it may take, up, down, left, and right. All actions have an associated transition probability that tells us what happens to the robot under an action. A state has an associated value a robot may receive, also known as a reward function, which defines how favorable it is to transition to that state. Gamma is a discounting factor that tells us how we encode and quantify how much each reward is worth in the future. Given this MDP, we want to maximize the robot's reward it receives under the environment. Okay, given this grid world example, where the purple and green tiles are exit states, the primary goal of the robot is to exit the environment and maximize the amount of reward it receives. Given a reward function, we can solve for the optimal policy, which you can see here denoted as these arrows. The policy gives us the best actions to take under any of the state of the grid world. So if you take a look at the high gamma grid world and focus at the states closer to the bottom right, those states are a few transitions away from exiting, but the robot's policy prefers to head towards the purple tile. This is interesting behavior is due to the high gamma factor encoded into the robot, where the robot takes into consideration long-term rewards to be almost as good as short-term rewards. Now we look at the, conversely, the robot dashes for the exit as soon as possible and heads directly to the green tile at the bottom right corner of the low gamma grid world. The robot in this environment is myopic and does not value future rewards as much as short-term rewards. Changing the gamma to a lower value causes a robot to be short-sighted and wants to exit the grid world as soon as possible. So how do we learn from a demonstration? How do we solve for a policy not knowing what a demonstrator is trying to accomplish? Well, in the last example, we could see that the robot's goal was to exit the maze and maximize its reward. For a standard reward linear approach, we could learn a policy given a reward function, but the distinct feature of a Bayesian inverse reinforcement approach is that we do not have access to the reward function of the demonstrator. The reward function is what we want to solve for to understand the goal of the demonstrator. So one way to figure out the reward function is to guess. Is it a good guess or not? What would the human have done? The Bayesian reward learning approach accomplishes this by a Monte Carlo Markov chain method, by generating multiple reward functions and estimating a reward function that makes the demonstration appear likely. Like, I will delve into this deeper soon. So if you take a look here at the top MDP here, if you take a look at the grid world, you can see that the reward function is a bad estimate. The top grid world's reward function does not reflect a reward function that matches the demonstrator's action. Now let's take a look at the bottom grid world and look at the reward function. The bottom grid world is a good estimate because the reward function reflects a reward function that matches the demonstrator's action. So let's review Bayes' theorem, where the posterior is the probability of seeing a hypothesis is true given some evidence. The prior is a probability a hypothesis is true before any evidence. And the likelihood is the probability of seeing the evidence if the hypothesis is true. And the alternative prior here in the bottom is the probability of seeing the evidence. So we take a Bayesian approach to reward learning, where we want to have the distribution over reward functions that look likely given the demonstrations. Using Bayes' rule, this is proportional to the likelihood of the demonstrations given the reward function hypothesis and the prior over the reward function. So the likelihood of set of demonstrations given a reward function hypothesis R is how likely the demonstrator is to have actions in each state. Assuming that they're trying to optimize their reward function R, the equation gives higher likelihood to reward functions for which the demonstrator's actions taken by more rational demonstrators result in a higher reward than alternative actions. In the denominator, we have beta as a hyperparameter that tells us the confidence that the demonstrator is acting optimally, where values of beta closer to 1 presume a random behavior and larger beta assumes an expert demonstrator. Okay, the Q values is how much reward function we can get starting at state A, taking an action and then acting optimally afterwards. So in the denominator, we have the sum of all alternative Q values given all alternative actions. So in summary, our likelihood function gives a higher likelihood to reward function hypothesis that makes action demonstrators look better than alternative actions as it could have been. Okay, the standard Bayesian approach assumes Boltzmann rationality. This assumption that the demonstrator is acting with an intent and not behaving randomly. But what if we don't know how the rational demonstrator is behaving? Above, I've given examples of varying Boltzmann rationality, where low rationality exemplifies random behavior, while higher rationality exhibits intended behavior. So our approach in the summer, we take a Bayesian approach where we have a distribution or reward functions that look likely and also over the beta. So here, the research approach implemented this summer, as you can see, we were inferring over the reward functions and the beta, where we want to retrieve the reward function, the hyperparameter, to produce richer models of our demonstrations. We hypothesized that this would allow for a more robust Bayesian approach. So let's look at our data. In our bar chart here, the y-axis represents a learned policy in respect to the ground truth. The x-axis represents different betas given the standard Bayesian approach. The height of the bars represents the mean of our data gathered, and the error bars are shown as well. In our experiments, I ran a standard Bayesian approach and inferred over possible reward functions given Boltzmann rationality demonstrations. with the varying assumptions of rationality. This was done to test the robustness of the standard approach. As you can see, when given wrongly assumed irrationality, the standard approach has trouble inferring a reward function. Specifically, when we have overestimates, when we overestimate the demonstrator's competency. On the other hand, when we underestimate, our demonstrator fares better than the underestimate, but not as good as a ground truth. So here is our underestimated, and this is our overestimation, and this is a ground truth. So can we do better? Now let's take a look at the result to the research approach. The approach generated a robust learning policy over the standard approach without knowing the assumed irrationality. This is the beginnings of promising work. In the future, research we hope to learn from different forms of human irrationality, as well as learning from multiple biases given a demonstration. And I will continue running experiments the few coming weeks. So let's take a recap on what we learned. We learned how to model a reward learning approach to a Markov decision processes, where we maximize our rewards. We also learned that a policy is generated given a reward function. Next, we learned about the standard Bayesian approach, where we learned how to model robots through a demonstrations. We also learned Boltzmann rationality, where higher rationality parameter assumes an expert demonstrator. So, and these are my citations. And I'd like to give a special thank you to my mentor, Daniel S. Brown, for guiding me through this summer, and also to Anka Dragon, our principal investigator, and to Nicole Evans, Tony, and to Sam, and to my mother, my father, and Kelly Horner, the method director at Cabrillo College. And this work was supported by the Hopper Dean Foundation and the National Science Foundation Award. And then if you have any questions, let me know.
Okay, we've got a question in the chat, but things are moving so fast, I've got to find it. Which language or libraries did you use to model the Bayesian approach?
So I implemented this in Python, which is relatively slow. And what I did to kind of optimize this, I had to learn Python as well. So I got to learn a litany of different things, which is Python, which was it's like a weird combination between Python and C. It's kind of, you just initialize your variables instead of letting the interpreter do everything, which is really cool.
Awesome. We've got Idris, another AI researcher, asking you, do you think AI can potentially replace all industrial jobs?
I think AI is very promising in the future, and I don't think it can replace all jobs, or who else would pay them, in my opinion. But I don't think that it'll facilitate a lot of jobs, and I think it'll create maybe more technical jobs that will like give higher paying jobs to people who manage these systems.
Another question from the chat. What was the most difficult aspect of this research?
The most difficult aspect of this research, what I found the most difficult about this research was, I think it was the concepts, like the big picture concepts. It took me, I was pretty nervous about it in the beginning, but it took a while, to kind of.
Emmanuel, I am so sorry. I accidentally muted you trying to let someone in from the waiting room.
Okay, no worries. The biggest or the most challenging thing was like the big concept or the big pictures at the beginning. But once I kind of got it, it got a little bit easier. It just at the beginning was kind of overwhelming, but then it got a lot better.
Absolutely. Had you ever taken a class even somewhat similar to this before?
No, I haven't. I've done a lot of programming and I've never done AI. I've always been interested. So I'm really, really grateful. I think this summer internship has really challenged me to get out of my comfort zone. And I really enjoyed this opportunity. And I hope to continue doing research in the future.
Awesome. Well done. Next up, we have Fayaz.
All right, so can everyone see my screen?
Looks good.
Awesome. So thank you everyone for joining today. My name is Fayaz and my research project is titled User-Centered Data Population Knowledge Graphs. So before I start, I'd like to thank my mentor, Justin Lubin, and my PI, Sarah Chasins, for hosting me this summer. It was a great experience. So as a small overview of my presentation, I'll give an introduction of the underlying ideas we had, such as web scraping and knowledge graphs. I'll then go into my methods, such as our first steps and our formative study, and lastly, I'll end off with our results. So first, I'll start off with my introduction. So picture a scenario like so. It's summer break, hopefully we'd like to go somewhere, and what better place to go than national parks in California. So if we go to their website, we'll see a list like so, where they have all the attractions listed in a list format. So for 4 elements, this looks somewhat approachable. However, this list quickly expands and again like this. So what if there is an application that can automatically convert this list into an elegant table like so, with all the information structured in an easy to read format? So this purpose of converting website data into a better format or output is known as web scraping. In web scraping, we start off by taking the website data. We'll then pass it into an application, which some magic happens and a code script is generated. And at the very end, we get an output. And this output can range for the user who's using it. So it can be an Excel spreadsheet or an animated image, for example. The problem with web scraping right now is generating this code script. Oftentimes, the problem is that the programmer would have to know the underlying HTML structure and also what content they like. So because of those 2 factors, it remains incredibly time-consuming. One of the popular formats to export and store data is known as a knowledge graph, where a knowledge graph works by taking in certain data, and it will convert it by storing the data like so, where each piece of data is represented by a blue dot or a node, and they're all represented by relationships. For example, a dog is an animal, cows eat herbs, and the like. And these knowledge graphs remain viable to companies such as Google, as they use knowledge graphs to provide better answers. Companies like Lyft and Airbnb also use knowledge graphs just because they allow the querying to go really fast. For example, oftentimes they'll ask for your location and they'd have to figure out as to what places are close to you and the like. So our intention is to bridge the gap of web scraping to include user-friendliness and the flexibility of writing scripts to hopefully export knowledge graph data, like so, where we convert a web page into a table or knowledge graph like so. So as a formal introduction to our project, our research question is, can we create an application for use by domain experts that parses web pages into knowledge graphs? So for our methods, in our 8+ weeks of research, we created several steps. One was to discuss our prototype in detail regarding the system processes. We plan to talk with domain experts in a formative study. We developed 4 approaches to present to them, and at the very end, we used their advice to finalize a working prototype. In discussing our prototype's functionality, we decided to refer to several literature articles, and one article which we decided to talk about was using flash extract. Here, what we liked about it was that it allows the option of highlighting to allow the user to select multiple objects. Here, as you can see, the user has highlighted the title and the authors. So this allows a visual confirmation as to what information they'd like. However, a key difference we decided to stray from was that Flash Extract decided to focus on arbitrary relations. What we mean by that is that we plan to focus on web pages, and that's generally more structured than, for example, a research paper and the like. So because of that, we allow our application to work faster and work smarter for our purposes. And so with this paper at hand, we decided to formulate 4 several ideas as to how we can create a prototype. One being a keywords option, where the user, for example, would type in several keywords, and our application expected to be smart enough to figure out a table to generate. Another option that we generated was a guessing column sort of approach, where the user would continually select the web page and click on certain content they'd like for the specific information. A third approach we had was using Flash Extract's example of highlighting to continually highlight columns where they specify which information they like. A fourth approach we had was highlighting rows, somewhat similar to highlighting columns, but instead we're highlighting different content each time. So for our results, we came up, the domain experts gave several ideas as to what they liked. One was using a live feedback approach to make sure the user at least knows that they know what they're selecting. A second approach was modifying the tables, where the user would continually modify the table until they get the right table they want. Oftentimes in their work, a table is generated, but they can't modify it and they have to do another demo. So that becomes incredibly time consuming for them. And a third approach they had was using option number 3, the column approach. So although we wanted to target all these advice, there were several constraints which we had to, which caused some problems in our research path. One was being the time, unfortunately. So our application deals with the front end and the back end work, where the front end work would have to be user friendly, while the back end work should make sure that our application works on everything and with fast results. So to finalize how our prototype would work, we finalized a system overview of our prototype in steps. The process of how our application should work is that they'll take a sample web page. Our program should go into the HTML structure to find that actual element, and from there go up the classes to find the common ancestor. And this is all the pre-processing stuff. At the very end, we'll take this ancestor and we'll give our actual synthesizer a sort of input-output examples, where we pass in those HTML classes and the actual element, where here it could be their class and the actual phone number they want. We'll pass this all into a program synthesizer, where some magic happens and a whole script is generated basically. And with this generated DSL script, we'll essentially, also before I mention, oftentimes just to specify, the HTML web page is often very structured where there's an unordered list. So we tend to use this sort of structure for better purposes, where each structure has a sort of main header and consequential items. But yeah, at the end, we'll pass in our DSL script, we'll pass it with the actual HTML web page, and our application should generate our table. So since we now finalized our prototype and its system overview, we had to decide between working with the front end or the back end. And I decided to focus on the back end work, where here we would use program synthesis, essentially generate this sort of script automatically. And I want to stress here that the app does all the work for us and the user doesn't have to do anything. So to better explain our work, we designed a sort of prototype which can sort of display as to how our application should work. So for example, we'll have this national parks webpage. We'll open our application. We'll select the title of one application or national park. We'll select the other national park we want. And if we automatically press this button, the program will generate a script automatically. That script will be passed to the application, and this whole elegant table will be provided. Similarly, we can run it on a Yelp webpage, for example, for all the restaurants in Berkeley. We'll select one element here. We'll select the title of another restaurant, and automatically we have this table generated. So those are some basic outlines of how our application would work. So for our future work, obviously there would be some things to focus on, being the backend where we can hopefully increase the speed and make sure it works on more websites. Another one is focusing on the front end where we can make sure it looks as user-friendly as possible. Here are some we're excited, and for acknowledgements, I'd like to thank my professor and mentor once again for all their work, the TTE staff, Nicole Mcintyre, Sam, and Tony for all their work, my CS professor, Professor Chinhansa, for recommending me this program, fellow interns, and the audience for listening through this presentation. And this work has been funded by the Hopper Dean Foundation and the NSF. Thank you so much for listening once again. And I can take any questions if you like.
Hey, Fayaz, you might have hit on this, but when you're expanding this to other websites, what are some of the complications and like nuances that come in with how the web page itself formats its data?
So I sort of hinted at it, but yeah, that's a great question once again. But oftentimes a website structure may be unexpected than what we anticipate. So I think I've hinted to this earlier, but we try to focus on like a sort of main header list and consequential bullet points. So we'll focus on that structured list format. But there are times in a website will be like sort of weird where they'll have, for example, a list, and then the header at the actual bottom. So because of that, we have to find like very obscure websites to make sure it can work for everything. So hopefully that answers the question.
That's really cool. Yeah, thank you.
We had a question in the chat from Kayvon. He was asking, how does your program read HTML data? And is there a library specifically for that?
So we're using JavaScript as our main language, and JavaScript is powerful enough to actually select elements automatically on the web page. So we tend to use that to create our actual scripts, and we eventually pass that script using JavaScript to actually parse that web page.
Awesome. And there's another one in the chat here from Chris. He was asking, do you think that this could be expanded to mobile apps since they follow a similar HTML structure as well?
That definitely can be considered, yeah. So we've been using the desktop version, and assuming that it'll have the same outline, then hopefully it can work on mobile sites. So yeah.
One more question from the chat. How much did you know about this work going into this project? Had you done any web scraping or application design?
That's a great question. And actually, I didn't have any experience. I think it was like 2 weeks before this internship, my mentor, he sent some resources on JavaScript, HTML, and CSS. And I didn't know anything about that, though. It just been like a summer goal. So with this internship, I got like to actually study it. So yeah.
Awesome. Well done. Very good job. With that, we are going to move on to another presentation that references a scraping methodology, and that is Amy Matthews.
Can everybody see my screen?
Yeah, there we go. That's better. Perfect.
Right. Second. All right. Hi, everybody. My name is Amy Matthews. I am from San Diego Miramar College, and I'm happy to present my research to you today. It's titled Dark Patterns of Online Targeted Diet and Weight Loss Ads. So without further ado, let's get started. This is the roadmap of what I will be talking about today. I do want to say that I do have a trigger warning here about eating disorders, and I'll be discussing it a little bit further in my research. So what we're going to start with is I'm going to introduce you to the past studies. Then we're going to go to the implications of targeted advertisements, Instagram algorithms, methods of data analysis, my results and discussion, and future work. So what you're seeing here is actually an excerpt from an interview conducted by my mentor, Lisa Gack. She interviewed people who had unpleasant experiences with diet ads specifically, and she conducted 21 interviews in total. And we observed emotional responses to targeted diet ads, and were able to capture how users were anticipated, they perceived, and reacted to potentially triggering ads. The focus was on the intuitive eating community on Reddit, which consists of individuals recovering from disordered eating and repairing their relationship with food and exercise. So I'm going to read this excerpt out to you. They look at your demographics, and you're a young woman, and you're looking to stuff for health. Oh God, if you look up any stretching or yoga, immediately you get ads of yoga for weight loss, targeted yoga to shrink your stomach. I'm like, no, I just want to stretch. And what you're seeing here is actually that generalized nature of targeted advertising. And they just assume immediately when you're exercising or yoga or something in the realms of that, that you immediately want to lose weight. And this kind of prompted my research question, and I wanted to learn more about this. So my research question is, how do targeted ads and suggested profiles on Instagram specifically differ based on demonstrated vulnerabilities such as eating disorder recovery? And my second question was, what percentage of recommended content is authentic to the interests of the users, and what percentage is harmful to people recovering from eating disorders? So I love stats, and I feel like stats, there's no better way to explain things through them. So the big number that you're seeing here, 71.6 billion, is the weight loss market value, which is humongous. And Generation Z in America consists of 67.06 million. And among them, it's estimated that they spend about 53 minutes per day on Instagram, and that amounts to 297 hours per year. In another survey conducted among young people from the ages of 18 to 29, they reported being active users, 90% reported being active users and being continuously exposed to different content and images in this weight loss medium. I want to further drive the point to show you the correlation between social media and the weight loss industry by showing you this graph over here. On the x-axis is the audience in millions, and on the y-axis we have different countries. And this is the Instagram usage as of 2021. We see India leading, closely behind by United States, but I want to point you to actually a couple of countries that is coming in. Number 6 is Japan, and number 8 is United Kingdom. The next slide that I'm showing you over here is actually the eating disorders worldwide. And if you look at the right of your screen, you're seeing Japan with the highest rate of eating disorders worldwide, which was astonishing to me because actually Japan is a very small country. But they do come at number 6 on that Instagram usage list. Similarly, in India, actually prior to 2000, there was very little publications or reports of eating disorders. But in the last 15 years, eating disorders have been up on a rise, up to 10 times higher than that of previous decades. In the United Kingdom, it's estimated that 1.6 million people are struggling with an eating disorder. And here in the US, about 9% of the population will have an eating disorder in their lifetime. So I hope that you were able to see kind of how social media does seem to contribute to eating disorders among people in varying nationalities. So next, what I want to talk about is the Instagram algorithm analysis. While I was studying this, I managed to create this acronym, HAPE, with the attempt to make it sound like the word happy, but we'll just get going. So H, hashtag. Hashtags are the golden ticket to be able to grow your audiences and to target people who might be interested in your content. Every influencer knows this. So hashtags is a big player in Instagram. Secondly, activity. This is about you and I. So what type of content do you usually like or save or share? And how do you interact with posts in the Explore page? P is how popular is that post? How much engagement does it get and how quickly? Time is a big factor in the algorithm. And the next that leads ways into engagement. How longer do you linger on a post? So fun fact, if you spend about 3 seconds on a reel or a TikTok video even, it's counted as a view, and 3 seconds is so quick. So if you set your phone aside, or even if you linger for like a couple of seconds, the algorithm thinks that you are actually interested in that material, and you are more than likely to see similar content the next time you're on the app. So what I also just want to bring out a few more quotes from Lisa's interview that I found will help you be able to kind of understand how people feel when they keep seeing these type of ads. So I'll read them out right now. So the fact that it just keeps coming up is a little tiring, and I almost want to say insulting that it's still working. The questions in the quiz bring a lot of harm and trauma. These are still the things that are going to get to me. When was the last time you were at your ideal weight? They asked, to make you feel like crap. And basically from reading all of these interviews, it enabled me to do something called algorithmic auditing. And what that basically means is I'm fishing the algorithm, the Instagram algorithm, to try and understand a little bit more by actually creating a profile. And I tried to make this as authentic as possible, just like you and I would create a profile. And I took these phrases from her interviews, so like intuitive eating, binge eating, trying to get healthier, recovery, and I created this profile called Victoria Adams. So let's learn a little bit about Victoria Adams. Victoria, she is 20 years old. The reason why I picked this age is actually women who are in this age demographic are more likely to develop an eating disorder. She goes to SDSU. She's a nutrition major. She's recovering from binge eating, and she loves Abby Sharp. And for some context, Abby Sharp is actually an influencer mentioned by many people in their interviews, and she's a positive influencer. She promotes healthy ways of losing weight. And I want to show you kind of like how Victoria looks like and her profile. And the video that you're seeing here is her For You page. So this For You page is clean. What I mean to say by that is it's positive. It's only what she is seeing, what she chooses to follow. So it's good things. It's not in any way harmful. But what I kind of did is I took each of these posts and kind of started checking what type of hashtags appear under those posts. So that leeways into my next slide, which is my technical approach. So I identified 10 most popular hashtags on Victoria's Instagram feed. And from those 10 those hashtags, I scraped about 100 posts from each hashtag, and I used Python to do so, totaling in about 1,000 posts scraped. And using an optical character recognition scanner, I extracted the text from images, and I analyzed the type of post that I scraped. And from this analysis, I sorted them into relevant, harmful, and irrelevant. So next, I want to show you kind of how I felt seeing the post, and I want to show you, like, visualize kind of what was happening here. So over here, we see the hashtag body positivity. I think that's pretty self-explanatory, but when you look in the left, these are kind of the posts that leak into the hashtag body positivity. So this is a harmful / scam post, and they promote rapid weight loss via supplements. But on the right, you see authentic body positive principles. And then I have a few more examples here. So under health again, and also under binge eating health, which is actually even more specific type of hashtag. We have an app going on here called My Body Tude, and I was interested in this app. And I looked into them, and their system is you can see a trainer for 3 times a week for 3 hours, and it's $180 per week. So I do not think it's probably the best ad for somebody who's trying to recover to see, and not exactly the best pricing either. So I want to show you my results from this analysis. So kind of what I did is from those 10 hashtags that I scraped, I picked 4, mainly because of time. I picked 4 and I analyzed the type of post that I did scrape. And when you can look over here for supposedly binge eating help, right? Relevant posts in those 100 posts that I scraped were 53%. 53% were actually good. They helped, right? But 46% was actually harmful and wasn't useful at all. So yes, although the majority of posts are relevant, a significant percentage of posts served to users recovering from eating disorders are actually harmful and are promoting scams. And specifically under the hashtags of health and binge eating help, I observed that there were many posts about weight loss supplements, detox teas to drop pounds, booking appointments, or downloading apps in bios. And whenever a user actually downloads an app from the bio, the page actually gets a small commission for every redirect. Another thing that I was a little bit curious about was to see how text affected the popularity of posts. So text meaning on the image. So from these hashtags, you can see that indeed text in images affects the popularity on the Instagram Explore page, with the exception of body positivity. But when we're looking at the hashtag binge eating health, about 73% of those images had text on them. So kind of what my future work would be to automate the process of categorization of ads so that I could scrape a wider data set and understand how that works a little bit more. I would have liked to also create a plugin to correctly label the content of those ads coming in. And in down in the future, down the line, I really hope that they do create limits to material being posted on the platform and implement ethics in the technology department. So here are the credits of and what I use to make this this presentation. And I want to especially thank the Hopper Dean Foundation for funding my research, my professor Niloufar Salehi for always being there and giving such great feedback, and my mentor Lisa Gack, she was so helpful throughout this 8 weeks. And I want to thank Nicole, Tony, and Sam, and the entire TTE team and cohort for all of your support. Yes, thank you. And if you have any questions, you can ask me now, and you can find me at my email over there.
I have a question, Amy.
Yes, go ahead.
So what do you think was the most complicated part of this research?
Ooh, scraping. Scraping was very, actually on Instagram, they have limits to scraping. It's not technically allowed, but that slowed down my laptop a lot. And I had to, it was organizing that scrape data was definitely very difficult. So.
I want to piggyback on that question, on what you thought on the last question was how many scrapes are you allowed per day, or is it daily, hourly, or?
It's hourly. So when I scraped Instagram, I could do a maximum of 200 posts in an hour, and then I had to wait for like 2 more hours to be able to do it again. So it was a long process. Yeah.
Did you have to get an API to do that scrape, or did you just go to? Or how did?
Yeah, I kind of just used a source code from GitHub. So no, I did not use the API, but yeah.
We have some questions in the chat, including how did you define relevancy versus irrelevancy and helpful versus non-helpful in your analysis?
Okay, great question. So this is kind of why in my future work, I said I would have liked to automate this process. But what I did is I actually went in and checked each one of these posts and kind of the captions. So when you scrape, right, you get a metadata. Metadata being like you get your hashtags, the captions, and the pictures. And so using the captions that came with the pictures, I kind of checked what they were actually saying. So some photos would have detox teas on them, and then the caption it would say, this will make you lose weight in a week, or 7 pounds in a month. So something like that. So that's how I categorized the relevancy and irrelevancy and harm.
On that note, Isaac is wondering if you have any leads on how automating that process would work.
Not really, if I'm being honest, no. I feel like I actually just kind of learned Python through this internship, and I'm super grateful that I was able to. And yeah, I would love to learn how to automate it.
Awesome. Rocco is wondering if the data sets you collected, if they'd be useful to take them to Congress and force the FCC to limit this type of advertising.
I would think absolutely yes. I have all of them on my desktop here. I think it would for sure, because it is very damaging to people who actually might be trying to get over their eating disorders. So
absolutely. We got a great question from Afnan, which is, how do you think someone can protect their privacy in this age of digitalization?
This is a good question, but unfortunately, I feel like, okay, they give you options to turn off different ads and stuff, but they still seep through. So I really don't know. Like, I feel like you're never protected completely, it just always manages to kind of get to you and understand your personality pretty much.
Okay, our last question from the chat, I'm going to combine two, which is, why did you choose Instagram? And do you have any suspicions that TikTok might be as dangerous, or other apps?
Okay, yeah, good question. Instagram, I love Instagram, so that's kind of one thing. Two is Instagram is just so popular, and I feel like it's very visual, more than the other social media platforms. So those are kind of the reasons why I picked that. Secondly, TikTok. is huge. I mean, TikTok would have been another thing I would have loved to research. Actually, the Washington Post did do kind of a research of similar to me. They posted it on July 15th or something, and they created about 100 different profiles on TikTok and did exactly kind of what I did. And yeah, TikTok really reads you. You will see at a certain point the For You page just knows you a little too well. So yeah.
And my last question is if you would like to share with the audience what you'll be doing next.
Oh yeah, so I had the privilege of being accepted to UC Berkeley, and I'll be starting here on the fall. I'll be in the EECS major.
Awesome, congratulations. Well done, Amy.
Thank you.
I'm going to resume the recording before I forget. And hand it over to you, Kayvon, to share your slides in just a sec. And get us started.
Can everyone see my slides and hear me?
Yep.
Looks and sounds good.
All right. Well, hello everyone. My name is Kayvon Marise. I'm an electrical engineering and computer science major at Diablo Valley College. And I've had the opportunity to conduct research in the hybrid robotics group here at UC Berkeley, led by Professor Srinath and under my mentor Zhongyu Li. I'm going to present my summer research on a quadrupedal robotic guide dog with vocal human-robot interaction. So why do we even need a robotic guide dog? Each traditional guide dog has to be trained individually in a time and labor-intensive process. The skills gained from one dog cannot be implemented into another dog, and guide dogs may get ill or need to retire, which creates an issue of training and finding a replacement dog. A robotic guide dog would ease the burdens that come with a traditional guide dog. You could create one algorithm and implement it into as many robots as once. It would be able to communicate with the user, such as with a speech interface, and would have human-like intelligence, meaning, for example, it can understand exactly where you want to go and create a path while looking out for obstacles. So previous guide robots. The Ballbot is a guide robot that has both physical interaction and a speech interface. However, its main issues were that it is limited in uneven terrain and utilized a rigid arm for guiding, as well as its reliance on an Amazon Echo Dot, which meant the wake word was not customizable. The Mini Cheetah guide dog was much more maneuverable than the Ballbot. However, it utilized only physical interaction with a leash to guide the user, as well as it's difficult for the user to communicate commands as it relies on an external computer for commands. So we want to incorporate the goods of both previous guide robots into a single robot. We want to use both a leash and a speech interface. So why do we even need a speech interface? It allows for direct, explicit communication, meaning that the user can tell the robot exactly what they want. This in turn allows for more user control, the ability for more commands, as well as the ability for the user to choose a different target point without the use of an external computer. So our speech interface will be deployed on a Unitary Robotics A1 robot. We first needed to install a speakerphone onto the robot to send and receive audio data. We used speech to text to allow the robot to understand the user. We then used text-to-speech to vocally communicate with the user. And then we then send the goal location to the navigation algorithm if the user wants to navigate somewhere based on preset coordinates. So for speech to text, we're using open source code from 6SMURI. How it works is that it gets the audio data from the microphone. That audio file is then sent to the Google Cloud Speech API, which then uses speech recognition to understand what is being said. It then sends back the translated audio in the form of a string of text, which we can then use. For text-to-speech, we are using open source code from AWS Robotics. And how this works is that it listens to a speech topic for a string of text. It then submits that text to the Amazon Poly cloud service to generate an audio stream. That audio stream file is then retrieved from Amazon Poly, which is then played back into the speaker. Text commands from speech to text need to result in change in the guide dog, whether that's in where the navigation goal is or stopping at its current position. And speech to text needs to ignore all speech that does not contain the wake word, which we put as hey A1. The speech to text algorithm has a word dictionary that will search for keywords in the resulting text from the user and has preset coordinates based on those keywords. Speech to text then sends the navigation goal after understanding where exactly the user wants to go from that word dictionary. The guide dog's navigation gets those coordinates from speech to text and updates the target point. So for example, let's say the user says the wake word and then says go to the lab. That audio is then converted into a string of text, which then the algorithm is able to read and understand what the user wants. So if the algorithm sees that the words go and lab are both said by the user after the wake up word, it knows that the user wants to go to the lab. It will then send the lab's coordinates to the navigation goal node, as well as it sends a string of text to text to speech in order to respond back to the user. So now I'll show the simulation results in action. This is a simulated navigation map that the robot would map out using its onboard LiDAR. And the purple circle here is the initial position, meaning where the robot and the user are. The green cylinder here is the final position of the person being led. And the green box right here is the final position of the robot. And the navigation will take both of these into account when creating a path, which is seen right here in the green line. And once I start playing the video, notice how the algorithm ignores commands if not given the wake up word hey A1. Hey A1, take me to the lab.
Okay, navigating to the lab.
Take me to the office. Hey A1, take me to the office.
Okay, navigating to the office.
So for results, speech to text successfully ignored speech with no wake word, which we put as hey A1. Speech to text understood and translated the user's command into text. Speech to text sent the user's command to the navigation goal node and published a response back to TTS. And a goal is basically a point of connection within a data network. Text to speech successfully got that text and translated that response into an audible voice. And the guide dog's navigation was able to obtain the coordinates from the goal node and created a path to that goal location. So to conclude, having a speech interface makes it simpler for the user to send commands to the robot. We developed a successful speech interface. The speech interface algorithm communicates with text-to-speech and speech-to-text engines correctly. We were able to integrate the different engines and algorithms to communicate with the guide dog's navigation pipeline. And the main advantages of this work is that we were able to customize the wake-up word to anything we would want and are able to create custom commands fairly easily by adding them to the word dictionary. And unlike previous guide robots, we are able to have a custom wake-up word and are able to integrate this speech interface with a leash while using a maneuverable robot. So for future work, we are currently in the works of developing an algorithm to allow the guide dog to operate an elevator to allow for multi-floor navigation. In order to facilitate this multi-floor navigation, we are currently restructuring the robot's navigation to take floors into consideration, Having a multi-floor situation means that we would need to further develop the speech interface to set in coordinates that can relate to what floor the navigation goal is at. And the speech interface will need to be developed to allow for more commands, such as telling the robot to stop at its current position, as well as giving the user instructions when needed. And finally, we would need to further optimize the speech interface, such as making it easier to input new commands and new locations into the algorithm. And I would like to thank the Hopper Dean Foundation, the National Science Foundation, the Transfer to Excellence program, which is sponsored by E3S, my mentor Zhongyu Li, my PI, Professor Srinath, and the rest of the people who supported me throughout this experience. These are my references. And that concludes my presentation. Thank you so much for listening. And are there any questions?
Yeah, so I have a question, Kayvon. Also, great work and great simulation of the guide dog robot. So how would the guide dog robot work if it was like outside in a park where there's no wired internet connection, and how would it guide outside?
Okay, great question. So first of all, it doesn't require a wired connection. It actually uses Wi-Fi. And we could possibly alter the robot to use a cellular internet connection, but optimally we would want to later create an offline speech interface for that.
We have a question in the chat here from Darren. He was saying, do you think that the potential effectiveness of these robots might outweigh the comfort and empathy that dogs can provide for people?
I believe it could, because I think traditional guide dogs, they require too much maintenance. You know, you have to feed the dog, you have to groom it, you have to bathe it. And I think that's pretty difficult for visually impaired people. Mm-hmm. So I feel like a guide dog that would basically only needs to charge itself would be a lot easier and better for them.
Great, thank you.
Kayvon, great presentation. What was the battery life of the guide dog? How long was it able to run before it needed to be recharged?
I believe it would only run, I think, 2 hours on a single charge. So that's another thing that we would have to look into.
I had kind of a quick question. I was just wondering, like, I noticed that in your examples, you were using phrasing like A1, go to the office, or, you know, things like that. I was just kind of curious how you kind of inputted this data into the system. Like, how is it that A1 is able to know like what the office is and where to go for the office?
Okay, so as I said, there's a word dictionary in the algorithm. So it basically sees the word lab or office, and based on those words, it has preset coordinates on a map. So when you say lab, it knows where the lab is. It's preset.
Okay, cool. And just to kind of quickly follow up on that, is there a way to choose for the guide dog to go somewhere in a room? Like if you're already in the lab, could you say, you know, go to the other side of the lab, for example?
Great question. As of right now, that is, you would have to put that into the word dictionary if you wanted to do something like that. But that's something really great to include in future work.
I just want to ask a quick question. You mentioned about the word dictionary. Is that stored offline on the dot itself, or is it on the cloud services?
This is offline in the algorithm itself. So that does not require an internet connection.
So would that mean that I can't take a guide dog that's specifically for a lab and move it out to the park and have it move with me with this design? Is that true?
Could you repeat the question? Sorry.
So if the dictionary is offline, so it means that every dog will only have a very specific area it can go to. So you can't just take a single guide dog and go to a lot of different areas.
As of right now, unfortunately, that is true. We could possibly make a online word dictionary to allow for like a global positioning, but as of right now, that is limited, yes.
Last question from the chat, which is how might this technology deal with accents? Do you know yet if it does okay with varied pronunciations?
So for speech to text, we're using Google Cloud, which uses the Google speech to text API, which it's pretty good at recognizing speech even with an accent, but I don't think we've tried with a heavy accent though.
Great. Thank you. I love hearing the questions from TTE interns. I feel like you all are really thinking critically about research and great practice and great job answering difficult questions. Well done, Kayvon.
Thank you.
Next up, we have Idris, who worked in the lab of Professor John Canny.
All right. Great job, Kayvon, as well. All right, can you guys see my slides?
Looks good.
Cool. All right, so hello everyone. My name is Idris Said, and I work with my mentor Philippe and my PI, Professor John Canny, on news coverage diversity and source specialty. My main goal seeks to answer this question here. Which news sources specialize in covering specific topic categories? I essentially want to find the link between specific news topic categories like economy, crime, technology, and establish that link to different news sources like Al Jazeera, New York Times, or CNN. For instance, an ideal result would be something like CNN does pretty well and pretty good at covering topics relating to campaigns and elections, whereas BBC News specializes in covering foreign relations. Now, I'll go ahead and say that we weren't able to quite exactly answer that question, but we were able to, we weren't quite exactly able to achieve that goal, but we were able to answer some related research questions, such as how active is each news source in terms of covering, in terms of providing news coverage overall? How often does a particular source provide the best coverage overall? And what best coverage even means? Which source provides the best coverage for a particular topic? And which source most often covers a particular topic? In my research, we analyzed a data set that contained roughly 6,000 articles for nearly 500 events. Each event is given a phrase that describes the topic of that event, and each event is also made up of at least 6 different articles from different news sources. For each article, we were given a title, a news source, and a publication date. Here's an example to the right of an article that was published for an event about the passport gender identification, about an event, that had that topic. I do have this article as well, the content for it, but it was just too much to put on the slide. With this data set, we needed to measure the level of thoroughness and depth in each news article. So we decided to analyze all the entities in an article, and entities could be words, phrases, names of objects, organizations, and people. After this analysis, we would then calculate something we like to call a cover score, which gives us like a rough description of how much unique content was given in a particular news article. I'll go into more detail about this later, but it's essentially the ratio of the number of entities in one article over the total number of collected entities throughout all the news articles for a given event. The higher the score is, the more content and more unique coverage an article has. The smaller the score, the less content and less in-depth the coverage has in that article. After collecting the entities for each article, we needed to find an easy way to compare and contrast the different content in each news article for an event. So we decided to generate what I like to call a binary table, which is like a matrix of zeros and ones that outlines which news sources mention specific entities in their articles. If an article mentioned a specific entity, I would then place a 1 in the proper place. Otherwise, I'd put a 0. Here's a small snippet of an example binary table that I made for an event that was about the closure of an Apple Daily newspaper company in Hong Kong. As you can see here, Anadolu, CNN, Fox, and LA Times mentioned a next digital announcement, whereas Al Jazeera and BBC did not. As a result, this table became a very useful way to help show which entities were uniquely mentioned by specific news sources. Next, I'll show you how we even calculated the cover scores for nearly 6,000 articles. For each event, we generated a binary table that was sized based on the number of entities we collected and the number of articles that were published for different news sources for that event. We then selected each column separately and summed all the ones down the column for the entities of each article publication, and then divided that sum by the number of entities in our entity list. So in this way, the cover score can be seen as something like a weighted average for the amount of unique content that each news article has. Now that you kind of understand our plan and method, I'll go into more detail about how I actually collected my entities. Here you can see a visual representation of a Python tool called named entity recognition, and that was designed to extract entities and classify them into different categories like person, organizations, geographical regions, and dates, which is pretty impressive. This piece of text is actually from a CNN article that was published about the event that I mentioned earlier, the closure of Apple Daily newspaper company in Hong Kong. And you can see that the tool located people, organizations, and geographical regions, amongst other things. However, it turned out that simply collecting extracted entities was quite problematic because sometimes I would collect too many duplicate entities or entities that look different but reference the same thing. And we want each entity to be unique in our collection. Otherwise, a lot of our entity rows in the binary table would just be redundant and the cover score won't be as accurate. This problem ended up taking a lot of time for me because I would try to design algorithms that would remove the duplicate entities, but those algorithms also ended up removing entities that I wanted to keep. So that was unfortunate. Fortunately, my mentor Philippe recommended that I use something called neural coreferencing, which helped solve this problem. The neural coreferencing tool was an extension of a Python library that helped identify all the duplicate entities and all the entities that reference the same thing. Using neural coreferencing, I was able to just keep one unique entity and ignore all the entities that I didn't need. A cool example is this line here with Jimmy Lai in the last line. The tool was able to locate all the different instances when Jimmy Lai was referenced, even when those instances were pronouns. Here's another cool example that I made individually. You can copy this link and try it out yourself. This website can take in a piece of text and make connections between different entities. My example is Idris Said is presenting his research right now. Mr. Said also loves coding. And the numbers that you see here in the red are calculated probabilities for each link between entities. And you can see here that it made a high probability link between Idris Said and Mr. Said. And it also suspected that his could also be referring to me too, which is pretty cool stuff. Now, after collecting our unique entity list and generating the binary tables and calculating the cover scores for around 6,000 articles, which took a few hours, we began to see some results. The right graph analyzes how often each source generates the highest cover scores. From the graph, we can see that the UK Independent newspaper generated the highest cover scores most often, with India Times and The Guardian following. Now here is a scatter plot which plots the length of an article versus its cover score. From this plot, we can tell that most of the time, the shorter the articles, the smaller the cover scores. And this makes sense because smaller articles will tend to have less content and less entities mentioned in them, which will correspond to less ones down the column and therefore decrease the cover score in the binary table. Here's another scatter plot, which plots the number of published articles for an event versus the highest cover scores generated amongst those articles. And from this plot, we can tell that there will be higher cover scores for events with fewer published articles. The reasoning for this is that when events have many published articles for them, our collection of entities will be much larger because we'll have much more content. And as I collect more and more entities, the cover scores will get smaller and smaller because the cover score, if you remember, is the ratio between the number of entities in one article over the total number of entities across all the articles for that particular event. Now, here's an outline of a list of events that were all about a particular topic, and each diamond corresponds to one event. For each event, I'm also showing the source that generated the highest cover score, as well as the cover score that the source generated. So you can see here that CNN did pretty good with covering events relating to the building collapse in Miami, maybe perhaps because CNN and Miami are both located in the South. And also here you can see that India Times did pretty well with covering events that happened in Indian regions. The top right is about a commission established by the government of India. Or I didn't mention that, but this also part is also about the COVID vaccine distribution in Indian regions. Now I'll show you a table that shows a list of topics, the sources that cover those topics most often, as well as the sources that scored the highest for those topics. And you can see here that sometimes the sources that give the most content aren't exactly the same as the sources that scored the highest. For example, on the topic of China's Communist Party, LA Times covered that topic most often, but the New York Times scored the highest for that topic. And however, you can see here that the topic of the Ethiopia conflict, the UK independent newspaper showed up for both categories. So it was pretty interesting to see those differences. Finally, I grabbed all the news sources and figured out the topics that those sources were good at covering, meaning that they generated the highest cover scores for those topics. If we look at the best covered topics for Al Jazeera, we see that Al Jazeera was pretty good at covering the soccer game of Italy versus Spain and the Beirut explosion, among others. Whereas The Guardian did well with covering the Australian COVID live update and Trump's lawsuit plans. Now, if we had more time, we could tie these topics that I mentioned to general news categories like sports, foreign relations, or politics, so we can identify a general news specialty. We could then perhaps implement the system onto an app or a website platform for easier access. And I think we also still need to process a lot more data to determine more accurate trends in news coverage for specific news sources over time. Finally, I wanted to give a special thanks to our TTE program director, Nicole, my mentor, Philippe, my PI professor, John Kenny, the TTE program assistants, Tony and Sam, the TTE cohort, and Professor Marty Hurst and her lab group as well for letting me participate in their group as well as with Philippe. And I also wanted to thank the Hopper Dean Foundation for funding my internship. Thanks to you all, I was able to learn more about research itself and what it takes to be a PhD student. Thank you everyone for listening to my presentation. I'd be happy to answer any questions that you might have, and feel free to shoot me an email if you want to discuss anything else.
Hey, Idris, I have a question. So great work, by the way. Do you aim to incorporate maybe something like images into your coverage score as well? So for instance, maybe some news sources will be the first to obtain a unique image, whereas some news sources would just like reuse that image from the original one.
Oh, that's actually pretty interesting too. I think, yeah, our research group is kind of focused on something like called NLP, which is like natural language processing. So we just focused on the text, but that'd be pretty cool if I can analyze the imagery as well in the content.
Idris, could you maybe go to slide 15, and Darren has a question about your metrics.
Yeah, sure. Let's see, 15, yeah.
Can you actually go to the next one? Sorry.
Yeah, sure. This one?
No, I think it was 16. Sorry.
Oh, okay. No problem.
How was the highest scoring source calculated?
Yeah, so like for each event, I was able to determine like which source scored the highest by just finding out the maximum score, and I was able to tie that to each event, and then from those events, I was able to tie those events to specific topics, because sometimes like several events will occur for a separate topic, and so I kind of grouped all of those events in given topics and found out for each article publication which one had the highest score. And then I was able to go from the score to the source. If that makes sense.
Yeah, okay, thank you.
I was just, oh, go right ahead.
Oh, no, that's okay, Sam. I can go after you.
Okay, sure thing. I was just wondering how and if your model kind of accounts for bias on the part of the news agency. Like I was just kind of wondering, for example, one agency could put a lot of like true information about an event, but all of it is kind of directing you towards one perspective of how that event happened. And I was just wondering if there was any way that your model accounted for that.
I don't think so for now, to be honest. I kind of like see like there will be some issues with my methods because like I'm just allowing the system to collect entities for me, and the system isn't smart enough to know like whether a news source has some bias, and so it just collects like nouns and pronouns, and it will just kind of generate in my list. So I'm not able to like really determine if the news source had any bias.
Yeah, it's an earlier stage of the research project. That makes sense. Thank you.
Actually, my question was very similar, but going a step further, how do you make sure that your own bias or the bias of the operator or the person who generates algorithms or runs the algorithms is not influencing, because these are topics that we all have probably different opinions about it or not. So how do you prevent this in a study like this? And by the way, really great work. I enjoyed it a lot.
Yeah, thanks. I think my bias would probably be like, I guess in the methods that I use to collect my entities. And if I have like less effective methods, then that I guess would come from my own bias. But I think to counter my bias is to kind of like not look too much about the content, and then just try to like use a lot more methods and combine them all to just make sure my entity list is like as accurate as possible and can account for the bias from other news sources like Sam mentioned. And then I wanted to do more than just like calculate a coverage score, because I think the coverage score might be a little too, it doesn't hint at the data as much as well. Like it's kind of like a broad general description of like the unique content. So I think if I just like continue to work on more methods for collecting my entities and analyzing the data, I think maybe that'll probably like help my bias as well.
Thanks.
We have a question in the chat, which is, how do you plan to take notice of user reviews and what they think of an article? That's a big question.
Yeah, we haven't been really looking at user reviews, but I think that's probably a good idea, maybe just for like the data's sake, because we can find out what other people think of the news articles, and maybe they can tell us whether it's biased or not. But I guess we won't really have to trust their opinion, but I guess it's good for data's sake. I think that's a good idea for future work as well.
So I have a question really quick. I think that this is something that is a little more answerable, but I'm kind of curious, like on this slide, how are you able to kind of cross-reference these pronouns like their and his and stuff like that with the original subject? Like how is your model able to say like, this his is referring to Jimmy Lai instead of referring to some other person that was mentioned in the article?
Yeah, and I think it's probably like better explained here. I think the tool has its own models, and it kind of just like, I think it probably, I won't say like exactly, but I suspect that it goes through like a neural network that can like analyze different parts of each sentence, and then it'll generate like certain probabilities for links that it makes between different pronouns and actual nouns. So like you can see here, like the his pronominal right here, like it's probably saying that most likely that it's connecting to my name, Idris Said, but it doesn't know exactly, otherwise this probability like calculation would be higher. So everything is like based on probability, and it doesn't know exactly for sure if it's referencing my name or someone else's name.
Okay, that makes sense. Thank you.
We've got two more questions for you. Christopher wants to know, what was another challenge you had to face in your project except from classifying the entities correctly?
Yeah, I think another problem was kind of like doing this type of stuff, like finding out the trends after I collect the scores. And so like, I think kind of Darren was asking me a question about like how I was able to do that. Like I had to group certain topics and group certain events and make sure I don't lose any data in the process, and find out different ways to manipulate my results. And then like actually make these type of columns where I can find out which source like scored most often and which source covered the most content. And so that part like took a lot of time as well.
And then my question is to ask you if you'd like to tell folks what you'll be doing in the next year.
Yeah, for sure. So I've also got admitted to UC Berkeley in the EECS department. So I'll be looking forward to that next week, actually. School starts next week. So I'm really glad for that, because I've been looking forward to that for like a couple years now.
Awesome. Congratulations.
Thank you.
With that, we are going to move along to Ire from Los Positos College. Looks good.
Everyone, can you see my screen okay?
Yep.
Okay. Good afternoon, everyone. My name is Iretunde Akinshola, and this summer I spent my time in the Department of Mechanical Engineering at University of California, Berkeley, under the lab of Kosa Gaucho Lambert, and along with my mentor, Yukira Mirabito. And today I'll be talking about visualizing engineering design decisions. One of the things I learned during my time in the mechanical engineering department is that engineering design is an iterative process, meaning it involves multiple repetitions of creating prototypes, testing, refining them, and then creating new prototypes. This cycle continues till you develop the optimal design. However, this process starts with defining a problem, then gathering information, identifying solutions, before we get into this iterative process I just described. The design process and decision-making are two ideas that often cross paths. Engineers utilize the design process to make well-informed decisions on materials. Optimizing this process to a degree in which engineers are able to undergo this journey successfully is important. Doing so will yield in more innovative designs and products, lead to advancements in the field, and so on. The cost of not doing so, however, will be mediocrity in comparison. I learned a tool that can circumvent this issue, and that is visualizations. What are they? Visualizations are graphical representations of data that hold information regarding their subject. As we'll see in a minute, visualizations are able to communicate in a way that brings ease to the process of digesting and interpreting large data sets, which in turn increases the likelihood of one making the most optimal decision. Furthermore, accurate interpretations of visualizations can lead to innovative designs, discoveries, and acquired knowledge in the field. For these reasons, there have been an exponential increase in the use of visualization in business, tech, social media, and beyond. So, a man has two paths in front of him, but only one leads to the apple. How does he get there? Well, he doesn't get there by reading the next two lines. He gets there by visualizations. Visualizations. I apologize. Visualizations are powerful tools in the decision-making process because in situations like these, they can exploit human perception and leverage on our cognitive capabilities. Essentially, this means that with the help of visualizations, we're more likely to highlight specific details from a data set or identify trends or patterns at a much faster rate. So looking at this visualization, you can clearly see the path to the apple is going down path X and making a left after three path breakoffs. Professor Gaucho Lambert's lab carried out a prior study in the field of design and decision-making. The data they produced from that study was used in developing the data set for this research. In that study, there was a design task that 57 engineers participated in. This design task involved selecting the optimal design for a robotic gripping surface. The drawing in figure 1 over here, this depicts a close-up image of the robotic gripping surface that forms the design task. This entire figure displays the process through the design task, but I would like to draw your attention to part A. This was the portion that the engineers viewed first. Here, they saw 7 different designs of the gripping surface that can be differentiated by their geometry and their hardness. Some designs had 55 bubbles, while others had 3. However, within each design were 3 variations, as you can see over here, soft, medium, and hard, that they could view with a click. With another click, they were directed to part B. Part B holds section, this section holds detailed information on each design that they viewed after clicking one of these variations. From this point, they could either go back and explore other designs in part A or continue to part C and test their design and submit their design. It is important to note that the design task had a timer set for 10 minutes and engineers could only test 5 total designs. Given these constraints, I believed it was important to observe the path engineers took and analyze their decisions. The data from this design task was collected and served as the initial data set. From the initial data set, I randomly selected 4 individuals who submitted the optimal design. At this point, I cleaned the data so it only accounted for 2 variables. design name, and success rate. I extracted this new data set into 4 files and imported them into R, where I ran code to make scatterplot visualizations. Looking at this figure, we can see a visualization of one engineer's decision path and submitting the optimal design. The optimal design can be viewed here in the red circle. On the x-axis, we have the robotic gripper design, while on the y the y displays their success rate. The numbers on top of the data points represent the order of this engineer's decision path. Keep in mind, the black numbers are just designs they viewed, and the red are designs that they viewed and tested. We see that this engineer started off going around 3 designs. Started off at 7 soft, then proceeded to test 7 medium, went all the way down to test 31M, and circled back to 7 soft. I enjoyed observing this engineer's design path because I could see them run through the engineering design process. This triangle displays the process of selecting a prototype, then evaluating it by comparing it to a different design. This is a visualization of a different engineer's decision path. One thing that stood out to me when observing the design path was how they progressed to the left side of the graph after testing 19 medium. In addition, I took a closer look at this trend and noticed that this engineer started testing designs that had testing designs of the hard variation after testing 19 medium. And I'll talk more about why this might have happened in our discussion. So for our discussion, I'll be interpreting the design paths and trying to understand the design decisions. But first, let's go back to look at the journey of engineer A's decision path. So looking at engineer A's design path, I believe that 31M was an influential point for engineer A because at that moment, they discovered that designs with multiple bubbles are not effective. So they circled back to where they initially began, and from here they started testing. Designs that had less bubbles, with three hard being the first one and 1 hard following up. I think this realization at 19 medium caused them to find the optimal design, but it was intriguing what I noticed afterwards, that after finding the optimal design, this engineer proceeded to search for a design with a higher success rate. In this research, the optimal design had a success rate of 95%. So it's likely that they believe that 1 hard would have a success rate higher than 95%. There are no definitives on why 1 hard was selected and tested, but one theory I had was that this engineer continued to pursue designs with fewer bubbles and chose 1 hard in such of a design with a higher success rate. Now let's talk about engineer B. For engineer B, after this individual saw a slight increase in the success rate after testing 19 hard versus 19M, they refined their design strategy and selected a new design to evaluate. In this engineer's design path, I believe 7 hard was a very influential design. This is because this engineer had already identified that hard designs are more successful, so selecting 7 hard only confirmed these ideas. 7 hard is a hard design, of course, but it also has a few number of bubbles and tested better than the prior designs they viewed. So I believe that this confirmed the idea they had and led them to continue testing designs that had fewer bubbles, which led them to the optimal design, 3 hard. But just like engineer A, after testing 3 hard and finding the optimal design, this engineer also continued to explore other designs in search of a higher success rate. And this engineer also went to test 1 hard. Like I said before, there are no definitives as to why 1 hard is being tested after finding the optimal design, aside from the theory I just posed. But this is something we could explore in our future research. So what are the next steps? The next step would be to create a network visualization. These networks can help point out influential positions in the design path and efficiently visualize the relationships between design actions. I began this process myself, but my progress was limited by machine errors and time. My progress can be seen at the bottom of the slide, but the figure here in blue is an example of how network visualization should look. Predicting design decisions was something I looked forward to throughout this program. It would entail analysis and a lot of different factors, but would obviously have to incorporate networks. I want to give special thanks to the National Science Foundation for funding this research, my outstanding mentor, Yakira Mirabito, and my PI, Dr. Koso Gaucho-Lambert, all the TTE program coordinators, and my fellow interns. These are my references. Thank you. And are there any questions?
I have a question. That was very, very good and very interesting. Thank you so much. I was a little bit confused. So when comparing engineer A and engineer B, they both kind of took different decisions as to how they wanted to kind of make or create a design. Is that correct?
Yes. In finding the optimal design, yes, they took different decisions.
And I was just wondering, like, I think that this just has to do with human bias also, that every person kind of has their own idea or way of how they're going to design something, correct?
That is correct. Sorry.
Go ahead. Go ahead.
Okay. Yes, that's certainly correct. But with this design task, there was also some element of prior existing knowledge in the field and understanding what would be most suitable to successfully complete this task. So yes, bias is a factor, but once you start engaging in the design task, you are likely to pick up certain trends and notice certain things with testing different designs, and that can kind of influence your decision on what you do next versus just bias alone.
So the network that you have, it'll just have kind of a limit of what you can do, or will it expand later on? I don't know if maybe I'm asking all these questions.
No, you're fine. Are you talking about this network or these networks?
Yeah, like so if an engineer needs to choose between different options, I could see how this would work. But if you kind of had like an unlimited amount of options, I feel like there would be so many different ways that you could design something, and that's what makes science interesting and revolutionary, is that someone can come up with a new design that you never thought of, which could be optimal. I don't know.
Sorry, are you done with your question? Okay. So in this design task, there are only 21 options because I think I showed. So there are only 7 options, and each of these 7 designs only have 3 different variations. So there are 21 options in total. So each engineer would have to submit one of these 21 options to find the optimal design. I think that answers your question.
Thank you.
I have a question, Ira. Was cost a constraint in building or making a design, or was that kind of, or we just want to find the optimal design regardless of cost?
So the design task was conducted virtually, and so the engineers who participated just had to go through a link and participate in the online, almost like a game, you could say. And so there was just an app, I think, that collected like data on every click they made and everything they viewed. And so that's how we kind of built the initial data set. And that data set was done by my mentor.
Hey, Ray. Awesome presentation, by the way. So I had 2 questions, one and then like a follow-up. the participants knew ahead of time that they would have 5 iterations to figure out the optimal design. Is that correct?
That is correct.
So was there like any information that maybe their design process was influenced by knowing the amount of steps that they had? As in, like, when they get to the 4th step, maybe they jump up to like a 95% success rate, but they know that they have 5 iterations to pick the optimal design. So then they test another one, but maybe it's, you know, maybe it's more influenced by filling in the 5 design iterations rather than actually thinking that the next one is going to be more optimal.
That's true, and that's a possibility. I think that might have played a role in engineer B's path, because right after testing 4 designs, they just found the optimal design. But in this design task, you can still continue to view other designs even after you test 5. You just have a limit on the amount you can test, but you can view as much as possible within the 10 minutes.
I see. Okay.
You just wouldn't be able to test anymore after 5.
Yeah. Awesome, man. I appreciate it.
Yeah.
Does someone else have a question? I thought I saw an unmute.
Yeah, I was just wondering if there were any trends in general that you noticed in terms of, I guess, like the individual personalities of the engineers coming out and how they made their decisions. Like, I was just wondering if, for example, one engineer seemed like they were really dedicated to making it work with like a soft design or something like that. Like, were there any interesting trends that you had noticed?
Yes, that's not displayed in these slides, however, because I just focused on 4 who achieved optimal designs. But looking at the data set as a whole, I believe it has like 2,000 rows and 15 columns. So there's a lot to handle, and you see a lot of intriguing decisions being made by certain engineers. I think I remember seeing one engineer find the optimal design, but then submit a design that had only like 12% success rate. There are a lot of very interesting decision paths, but for this research, I just focused on the 4 who just got the optimal design.
Yeah, that makes sense. Thank you.
Awesome. Well done, Eric. Congratulations. Our final presenter of our 2-day research symposium is Afnan. And we have a special request for you all. We have limited internet bandwidth for Afnan's presentation. So I'm going to ask that, although I appreciate you being engaged, everyone turns off their webcam so that we can make sure that he gets all of the bandwidth he needs for his presentation.
Can you guys see this?
Yep, it looks great.
All right. Hello, everybody. My name is Afnan, and this is my presentation on my research on investigating the effectiveness of robust estimators. And thank you to my mentor, Bangwazu, for helping me with this. So before getting into the details, I want to give a background on what robust estimators are and why they're significant. So robust estimators fall under the wide topic of robust statistics. And there are a couple of assumptions that we make when we make statistical models. One of them is distribution of key variables, and the other is model specification. But the main purpose or the main difference between robust statistics and non-robust statistics is that robust statistics is invulnerable to changes in the assumptions. And if you add extreme outliers to the data, it won't change the outcome of the data set as much as it would in the non-robust statistics. So that's something to keep in mind. And in a nutshell, if you produce an estimate with a robust estimator and you add a very extreme data point, so you shouldn't produce a different estimator that's too different from your first one. So let's consider an example. Let's say we have an independent measurement of some quantity, for example, some distance, and it differs by random error. how do we find the true value? That's where the normal distribution comes in. So in probability theory and statistics, normal distribution is one of the most significant continuous probability functions. And sometimes it can also be called a bell curve or a Gaussian distribution. And a large number of random variables can be represented by this normal distribution. So this normal distribution can be produced by this equation, as you can see here, where micro, this is the mean, and omega is the standard deviation. And it's also defined by the probability density function. So let's say we have a function fx, and x is the random variable. So it defines a function which is integrated between the range or interval from x to x plus dx. And you say, what are these percentages? So this means that 68% of the data falls within one standard deviation of the mean. 95% of the standard deviation of the data falls within two standard deviations, and 99.7% falls within three standard deviations of the mean. So that's the basic outline of what a normal distribution is. But let's go to why we're doing this research, right? What is the purpose of this? The main purpose of this, or the main reason, is because outliers and data corruption is a fundamental problem in statistics. Not only actually in statistics, but just in general in data sets. Outliers and data corruption can, even one extreme outlier can change the whole data set. So it's important to solve that problem. Let's say we have a data set x1, x2 up to xn, where several of the samples are corrupted. How do we calculate the mean given the corrupted data, right? And then we validate, estimate the one-dimensional mean and median, and then we validate and estimate the 2D mean and 2K median. You're probably wondering what a 2K median is, but that's what I'm going to explain right now. So basically, a 2K median is used to describe the centrality of a point in a multivariate set of data. What does that mean? That means, like, if you have multiple dimensions of in a data, it can be used to find the median of that set or the mean of the set. And let's say, and this is the formula that we use to compute the 2K median. So assume we have data represented by x1, x2, up to xn, and all of them are in d dimensions. And let's say x1 is a vector, which is 0, 1, x2 is a vector 1, 3, it can be any number. So the 2K median is going to find a point, which we can call x here, and it's going to help us maximize the distance, right? And here you see the u. This can be seen as hyperspace or hyperplane. But let's say, for example, with us, we were working with 2 dimensions. So this can be seen as 2-dimensional vector. And this number here can be seen as any arbitrary number. So just that when we do the projection onto this x, is called u transpose x, which is bounded by u transpose xi, which is the upper limit, which is our basic sample and data points. It's going to maximize that distance. So this formula basically computes how many data samples are definitely larger than u transpose x multiplied by the u. U transpose x, if you confuse, basically, if you have a metric, if you have a matrix, and you like if you invert that matrix, or if you make a diagonal, that's basically the function of this. So this is basically trying to help us find one of the directions that this distance is the smallest possible. And you can see that the dx is a function of x. Function, and the x is the point, one of the data points. And then we find x such that x is equal to argmax, and this is going to help us find the depth. And usually this is one of the points that one of the points in x1 up to xn. So that's the basic kind of background on the Wikimedia. Moving on to methods, what we did. So we used Python. We generated a one-dimensional normal distribution, and then we generated an nth-dimensional normal distribution. It wouldn't matter what dimension because, but we used two-dimensional, and then we calculated mean and median with non-corrupted and the corrupted version. Then we compared the two, and then we also calculate the relationship of the mean with the sample. So why did we calculate the relationship of the mean with the sample? Well, that was to ensure that the theoretical prediction of 1 over square root of x is true for the regression. And we took the logarithmic value of xy, and the function is basically y equals c over square root of x, or equals to y equals cx raised to the power negative alpha. And we repeated this several times to get the average. So we achieve log x log y to plot, and y equals negative alpha x plus c, where negative alpha is the slope. And this gives us the rate at which the Gaussian mean estimator is changing with respect to the samples. And this lets us know if the data is corrupted or not. So here's the example of the first dimensional 1D distribution, non-corrupted version. Here on the left side, you see here's the mean values, and on the y-axis and the x-axis is the samples. And you can see this is pretty similar to a 1 over square root of x graph, where the mean is approaching 0, and that's what we want. And when we took the logarithmic function of this, we got the best fit line to be negative 2.54 minus 0.5x, where alpha value was 0.5, which is what we wanted. So that was for the mean versus the samples. And this is for the median versus the samples. You can see pretty similar to what we got for the mean. And on the left side again, here's the median, and on the x-axis is the samples. And we took the logarithmic function and found that alpha was 0.5. And then we generated a two-dimensional distribution. We generated about 5,000 samples. And then we took the mean for a part of those samples. And here you can see on the left side, this is the mean. This is the samples, amount of samples, and this is the mean. And again, taking the logarithmic function, got pretty similar to the alpha value of 0.5. So then we corrupted the one-dimensional distribution, the one-dimensional data. We corrupted 10% of the data. And why we choose 10%? Because it was, if we did more than 40% or 50%, then that would render the whole data useless. So it was important to keep it in mid-range. So we corrupted 10%. And how we did that, we basically sorted the data into a list, defined the mean and median, made a new list for the corrupted data, and then corrupted 10% of the data by corrupting any nth value, and then repeated that process to get accurate results. And then we got these results, right? As you can see, comparing the mean versus the median is drastically different. This one mean is very different from the one we calculated before when it was non-corrupted. But the median is very similar to when it was non-corrupted. And why is that? That's because median is more robust than mean. It doesn't change due to the because of the outliers that much compared to the mean. So to avoid some kind of like nonsensical results, we use median instead of mean for when we know or when we think that we have corrupted data. And this means that it's less responsive to corrupted data than just using the just taking the average. And then we corrupted the two-dimensional data. So this is kind of a zoomed out version, but here you can see we basically changed the ith value to 200, and that's why we see this difference. So here you can see this is for the two-dimensional. This is the mean versus sample graph, really all over the place. But again, on the right side, we see a prediction in the two. But the prediction is a more robust estimator. So what was the conclusion? So we concluded, especially with corrupted data, and if we're able to complete the implementation of Tukey median in Python, it should make the computation much more efficient. And because currently it's only, there's no package for that. So I think it would make it way more efficient for computations. Yeah, so currently we're working on the Tukey median, and hopefully in the future we work on filtering, which is another algorithm. And then we can compare those two algorithms to see which can be more efficient. Here are the references. And I would just like to acknowledge everyone who supported this research. First of all, my mentor, Bangwa Zhu. My faculty host, Jianta Zhao, Nicole, Tony, and Sam, the whole TTE staff. E3S for hosting this research, Hopper-Dean Foundation for funding this research. And I just like to end with this quote: research is formalized curiosity. It is poking and prying with purpose. I just thought it summarizes really well. And thank you for your time.
Any questions?
Sorry.
I was just going to say, we have a question in the chat from Chris. He was just asking, what was the most challenging part of your project?
The most challenging part, well, right now, the most challenging part is implementing Tukey median in Python. Because currently there's only a package, it's only in R, but yeah, implementing it in Python is quite difficult. But other than that, I would say just, implementing statistics in Python and coding was quite of a new challenge for me. But yeah.
Awesome. And
I have a question for you. It's Michael Portal. You started out your presentation by introducing a normal distribution, which is it's a very specific distribution, highly idealized. Assumes a highly idealized system. Can you just why you chose this distribution, and how is your method depending on the distribution? Let's say turns out it's a different type of distribution, the data. How hard or easy is it to adjust it?
So why I used normal distribution as an example was because like a large number of random variables can be represented by this, and it's mostly used in physical sciences and economics as the most common way. And it's also used in for example, in when you want to represent population distributions. And I think that's just why I included it, just as a basic background for research. And we started off with our research with 1D, one-dimensional normal distribution. So that's just why I wanted to.
Okay. So it's just an example. But your method
Yeah.
doesn't depend on what type of distribution you use.
Not really. Yeah.
Okay, thanks. Great work, by the way.
Thank you.
We have 2 more questions in the chat here. I'll start with Darren's. He was just wondering, what was the most surprising part of your research?
See some questions here. So what was the most surprising part of my research? I guess it was to find that median is, I guess first was to learn about Tukey median. And that was pretty good. It was a new concept for me. And thinking of how to find median in multiple dimensions, I never really thought of it, but it was good to research that and learn about that. And yeah, using median to find mean, that was kind of surprising for me. But yeah, I would say Tukey median was probably the most newer experience for me.
Great. And Emmanuel had a question as well. What was the most enjoyable part of your research?
Enjoyable and dreadful was like basically, as I said, about learning about the Tukey median and trying to implement it, which I'm currently doing. And enjoyable, of course, is when you get results when you code, and then at the end you just you find out that it works, and yeah, I think that's the most enjoyable part.
Awesome. Thank you.
Thank you, everyone.
I think that brings us to the end of our 2-day research symposium. Congratulations to all of the interns who participated and shared their hard work, especially as first-time researchers. And thank you to everyone who has attended throughout the 2 days to support our interns, or maybe is watching the YouTube video.